So in this video, we want to discuss why regression wouldn't work perfectly, right? Why regression wouldn't work perfectly? Because we said some algorithms, like the ones that we are going to discuss here, logistic regression, we are going to discuss in this chapter rather, logistic and LDAs, they classify based on calculating probabilities, right? They calculate probabilities and they give they give the person the class that is the maximum probability. The maximum probability will then give the person the class, right? So if the maximum probability is female, let's say we've calculated our probability and it says this person is 70%, the 70% probability that the person is female, and then so 30% that the person is male, we're going to conclude that the person is female. So someone will be like, but probabilities are what? Are numeric. So why can't we use regression? Why can't we use regression? Let's discuss that question now. This is because let's imagine we have three conditions where we're in an emergency room. We're in an emergency room of a hospital, right? And there are three diseases that we're treating there, or three conditions. Let's just say conditions or let me write conditions. Three conditions that we're treating there, right? So the first condition is going to be whether a person has stroke or drug overdose, stroke, drug overdose, or maybe the person went through an epileptic seizure, like that, right? So epileptic seizure. So these are the three classes that we have. Perfect. Cool. So now when you want to do regression, you'll be like, okay, cool, it doesn't matter, these are qualitative. What I can do, someone might say, okay, what I can do is I'm going to encode them, or I'm going to code them this way. Person who has a stroke, I'm going to say it's number 1. Person who has a drug overdose, number 2, and then person who has epileptic seizure is going to be number 3, right? And then run your regression, because it's going to be, we're going to have some predictors, maybe predictors like blood pressure, sugar level. Let's just say sugar level in the person's blood, things like temperature. We take the person's temperature, etc, trying to predict what condition the person has, right? So the person will be like, okay, regression does qualitative or numeric. It predicts numeric values. So I'm going to replace every stroke with a 1, every drug overdose with a 2, and every epileptic with a 3. Which means in my training data, I'll have this BPP, whatever it is. If it was stroke, I'm going to have 1 instead and try predict that column, right? I think you understand what this person number 1 would have done. Cool. So now we can use least squares to fit a regression model. But this encoding, there is a problem inherent with this encoding. You remember when we're doing income levels, right? When someone says 20,000 Rand and another person says 30,000 Rand and another person says gets paid 40,000 Rand, right? What is the difference between these? The difference is 10,000 Rand, and it makes sense, right? We can make sense that it actually makes sense. The difference between person C's salary from person B is 10,000 Rand. It's something that actually makes sense in normal language. In reality, it makes sense. We can get the difference here. And what is the difference between person A and B's salaries? It's 10,000 Rand. So the difference here also makes sense. It actually makes sense to compare these salaries like that. It makes complete sense. And here we're saying it's 10,000 Rand between A and B and 10,000 Rand between B and C. So it means the distance here is equal to the distance there. It makes sense. It's logical. It actually applies in real life. It makes sense. Let's look at our encoding now. When we encode, we're saying the difference between 1 and 2, it is 1, right? And the difference between 2 and 3, it is another 1. So what are we implying here? What is our encoding implying? it's implying that the difference between someone having a stroke and drug overdose is the same difference as someone having drug overdose and an epileptic seizure. Does that even make sense logically? Like, can you even speak like that? I don't even know how to translate that, right? It's different from something that is naturally numeric, right? Like income levels. Here we've taken conditions or diseases and made them numeric. And when we made them numeric like this, 1, 2, 3, we've sort of put distance between them. This one difference between epileptic and drug overdose, what does that even mean? What is one? Is one rand, one drug overdose, one epileptic? It doesn't mean anything, this one here. So forcing this encoding will not work, because it creates the illusion, or it creates the thinking that there's actually a difference or a distance between the conditions themselves, right? I wouldn't know what severity level a stroke would be compared to a drug overdose and compared to an epileptic seizure. It's difficult. We can't put numbers to that, right? So that is one problem with this encoding. Another problem with the encoding is one can use different encoding, right? Someone could have said my stroke will be number 2, my drug overdose will be number 3, and then my epileptic seizure will be number 1. Someone could have done that. And if this encoding, the first one that we had, was true, it means the second one should also be true. Why wouldn't it be true? Why wouldn't it be true? If you remember from linear regression, when we're encoding our qualitative predictors, we're saying if someone is a student, we call it 1, and if non-student, 0. It also applies that if someone is a student, someone could have said 0, and someone non-student 1. Both of them apply. It's just the interpretation of the betas that are going to be different, but the results will be the same of the prediction. So cool. If the results are going to be the same for the prediction, now here, imagine if someone has a stroke, this person would predict a 1 and then say, oh yes, a stroke. But for this person, a 1 means epileptic seizure. You see, it means epileptic seizure. So this does not bode well for our hospital if we're trying to predict here, which means we diagnose people wrong, right? If someone predicted a 3, let's say this nurse with their encoding ran a linear regression and then predicted a 3. When a doctor comes, they'll go to their board, they'll be like, oh, you predicted a 3. Okay, so I'm going to treat the person for drug overdose, right? Because prediction, when you're doing quantitative variables like that, when we did for linear regression, it was the predictors that we were encoding and not the predicted value itself. It wasn't the predicted value itself. We're encoding the predictors. Things like your BP level, your student, gender, whatever it is. Those are the ones that we're encoding, not the income level or the predicted the Y. We're not encoding the Y, right? Because the Y needs to be predicted the same. It will be the betas that will be different, but then they will lead to the same prediction, right? If we encode the predictors. So those are two problems that are going to happen with linear regression. So someone might say, so linear regression is useless. It is not really. You can do a bit of classification with linear regression. If you have a binary classification, if you have binary classification, then it becomes possible for you to say, let's say someone is female and then someone is male. Then maybe you can use linear regression, because here, let's say your female can be coded as 0, could be coded as 1, and then your male can be coded as 0, right? So this linear regression, it can be fit here and predict, let's say, male or female. If, let's say, when you do your Y, if it's greater than 0.5, you might say the person is female. If Y is less than 0.5, or your probability is less than 0.5, you can say male. So that is much easier. But extending it beyond binary situation becomes much difficult. So even in the binary situation, when you're doing classification of a qualitative variable, let's not think of linear regression. Let's think of classification algorithms, like the one we are going to discuss in the next video, which is called logistic regression. That one is much better. So let's see how we can use logistic regression to do better classification than using linear regression.